Okay, so here is a basic physics problem involving quadratic functions. So it says a ball is thrown with an initial velocity of 64 feet per second from a start height of 192 feet. And they give us an equation, so they give us this whole equation here. It says, and our first question is, what is the maximum height the ball reaches? At what time does it reach it, and what is that height? Our second question is, when does the ball hit the ground? So at what time does our ball hit the ground? And our last question is, when is the ball at 112 feet? When is the height of the ball 112 feet? Okay, so the first thing I want to do is I want to take these values we've been given and I want to plug these into our equation. That shouldn't be too crazy. So we'll start working on number 1 here. All right. And we know that our initial velocity is v0 and our initial height is h0. So let's plug those in. So h as a function of time equals negative 16t squared plus v0t plus h0. I'm going to go ahead and plug in our values. So h of t equals negative 16t squared plus 64t plus 192. All right. Now, our next job is to find the maximum height. So let's draw a picture first. So the picture I want to draw here is going to be, we know it is a parabola, all right, and we know our parabola is going to be facing down. That's what our negative 16 means. And we know the ball starts pretty high, so what I'd like to picture here is the ball starting here. It gets thrown up like this, up, 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 down, 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 and ultimately hits the ground way down here. Remember, our height is 192 feet. Okay, and it ends here at 0 feet. This is 0 feet. Okay, and you can think about this axis really as time. Even though it looks the same way in space, we can think about this axis as our time axis. So our job here now is to figure out when the ball is at its maximum height, which happens to be the vertex of our parabola. That'll always be true. We want to figure out the time, and we want to figure out what this height is. It should be greater than 192. That's kind of a check. Our value should be higher than 192. Okay, so the formula I want you to know for the vertex, I want you to know that the x-coordinate of our vertex, in this case x is like our time, is equal to negative b over 2a. All right, so in this case, b is 64, so we have negative 64 over 32. Oh, excuse me, negative 32. Okay, so Vx equals 2. All right, so that means that after 2 seconds, because x is like our time here, after 2 seconds, our ball is going to be at this point. It's going to be at our maximum point. So we're halfway there. We found this time. It's 2 seconds. 2 seconds. And we would like to now find the height. So here's our function, right? And we have our x value. This is our time value, same story. But here we have t equals 2. So to find our height, how tall this is, all we need to do is plug in t equals 2 into our equation here. And that will give us the height of the ball at that time. Because the function is just a machine, and you give it an input, and it tells you how high the ball goes as a function of the input. So let's try it. So h of 2, because we're putting in 2 for t, equals negative 16 times 2 squared plus 64 times 2 plus 192. All right, so let's get out our calculator here. So negative 16 times 2 squared plus 64 times 2 plus 192. There we go. So h of 2 is equal to 256. This is a physics problem, not just a math problem, so we want to include units. And our units are given in feet, so 256 feet is how tall or how high the ball will reach after 2 seconds, which is the maximum height. So we could say here, this is 2 seconds, comma 256 feet. That's that point. Okay, so number 1 is all done. Knocked it out. Next question is, when does the ball hit the ground? Let's go back to our picture here. So in our picture, we can see that our y value, this is like our y-axis, right? And really we call it h because it's the height of the ball. So our height when the ball reaches the ground, what is our height when the ball hits the ground? Our height is 0. So we can say h equals 0 here. So if we can say h equals 0, then we can actually use our equation again as our tool to solve for t. And this is where it's going to get a little more algebra heavy, I would say. So what we'll do is we'll plug in 0, which is our height when the ball hits the ground, equals negative 16t squared plus 64t plus 192. So now I think to solve for t, we're going to have to do some factoring. So the first thing I see we can do, I think we can take out a GCF. So let's try to pull out negative 16. Let's see if that works. I think it will. So we'll have t squared. 16 divided by, or 64 divided by 16 is 4, so plus 4t. All right, and let's pull out my calculator here. So 192 divided by negative 16 is going to give me negative 12. And I see I made a mistake here. This should be a minus sign because I factored out a negative 16. Okay, now I think, and I'm hoping, that this will be factorable. So we have negative 16, and let's see, I think I can factor this as, if you get stuck on these, just go ahead and write it like this. Let's see, two numbers that multiply to negative 12 and add to negative 4. Let's see, maybe let's try negative 6 and positive 2. I think that's going to work. So plus 2 and minus 6. I multiply them, I get negative 12, and I add them and I get negative 4. So that seems to work fine. Okay, so now let's solve our equation. We can divide both sides by negative 16. Remember, 0 over anything in the world is just 0, equals t plus 2 times t minus 6. The next thing you have to remember, that you must remember to do well in these problems, is that when I have two numbers multiplied together like this, or two binomials, I can split it apart. So I'm going to take this, and I'm going to split it into t plus 2 equals 0, and t minus 6 equals 0. And there we have it. T equals minus 2 when I solve that, and t equals 6. Okay, back to our picture, because we have two solutions, and only one can be right. It says, when does the ball hit the ground, right? So we want to know the time at which the ball hits the ground, all right? And we know from kind of, being people and living on planet Earth that negative times are kind of weird. That doesn't really make a lot of sense. It's not going to hit the ground, 2 seconds before it's thrown. That'd be kind of ridiculous. So our answer is t equals 6. So the answer to this question is t equals 6 seconds. Incidentally, just as a side note, the negative 2, that's actually where this part of the parabola hits the axis, just as a side note. So it's not an extraneous, ridiculous, useless answer. It means something, but it's not what we're looking for in this problem. You'll see that a lot in physics problems. You'll take math and you'll use it in very specific ways. Okay, last problem. It says, when is the ball at 112 feet? So this problem is actually really similar to problem 2. We know that 112 feet is just a y value. Maybe it's, here. That's less than 192, so 112. And that's a y value, so I can plug that in for h of t. So I'm going to grab my h of t equation from over here. I'm going to write it again, but I'm going to plug in 112. So I'll write 112 equals, and I'll grab my equation here, negative 16t squared plus 64t plus 192, and if I can solve this, I should be able to get our final answer here. So I'm going to go ahead and skip a couple of steps because we already factored, so I'm going to just copy over our last factorization, and our last factorization result was this. Okay, so now I would like to divide both sides by 16, or negative 16 I should say. So 112 divided by negative 16 is negative 7. Alright, negative 7 equals t plus 2 times t minus 6. Alright. I don't love that. Let's see. Ooh, you know what we need to do actually? I made a mistake. This is an easy mistake to make. I'm kind of glad I made it so you guys can see what not to do. I shouldn't have factored that early. That was a mistake. Let's go over here. What I want to do is set this equal to 0 and then factor it. So let's try to do that. And when I say set this equal to 0, I mean make this side of the equation equal to 0. So the way I want to do that is I want to subtract 112 from both sides. So I'll get minus 16t squared plus 64t. 192 minus 112 is 80, so plus 80. And now we have an equation we can solve. This was kind of a mess, and if you see that on your test, then I want you to go back a few steps and see if you can get something that looks a little more reasonable like this. I'm much happier with this. Okay, so I think out of this equation we should be able to factor out a 8 for sure. Oh, actually even a 16. Great. So we'll say 0 equals negative 16. I'm factoring out a negative because I don't want this first coefficient. I don't want a to be negative because that makes factoring tougher. If I factor out a 16 here, so this is going to be minus 4, and then minus 5. Oops, and then there's a t right there. Okay, so I'm going to divide both sides by 16 again, so I get 0 equals t squared minus 4t minus 5. Now I need to factor. Let's think here, multiply to negative 5 and add to negative 4. I think we can do some combination of 5 and 1. Let's try minus 5 and plus 1. And that looks like it works. You can FOIL this out to double check, and I definitely want you to do that on your test. And we're almost done where I can set both of these equal to 0, and if I do that, I'll get t equals 5 and t equals negative 1. Okay? Are we done? No, because this is a physics problem. And usually one of these answers we're going to throw out, usually the negative one. Let's look at our picture again. Remember, our job was to figure out at what time does our ball reach a height of 112, and this is going to be the t equals 5 answer, not the t equals negative 1. And again, that's a negative time, which doesn't really have any meaning, so we're going to throw that answer out. So our final answer is t equals 5 seconds. Okay, great. Thanks. If you have any questions, feel free to put them in the comments below or send me an email. Thanks.